Hi everyone. So I'm making this video on Monday night. Um, so full transparency, I will not be in person for class this week. Possibly returning on Friday. I am out with. I tested positive for COVID-19 over the weekend. Um, so myself, my wife, and my 9-month-old son all did test positive. So we are working through that at home. At the same time, I will still do my best to be as available as possible for all of you. Um, and I'd like to start by kind of going over what I have planned for what this means for class. So I have our calendar pulled up here. So going back to where we left off before this 3-day weekend, we were finishing up section 341 all last week. I was saying that we were planning to test this upcoming Friday as we had really one last lesson, 342, before I was going to have 2 review days and a test. But then life happens. So with me being home and not in person, I didn't feel it was appropriate to review and test with the possibility that I wouldn't be there for any of the review days and even possibly the test on Friday. So what I did was we had planned a very short 1 week, like mini quest unit the following week with 3 lessons in there. So I'm building those lessons in, and also I'm probably going to change this, so I wouldn't copy this down just yet. But this is tentatively what I was thinking, but I might add in one more day in here of one more lesson that I just thought of that we can add in here. But basically, what we're looking at is we'll have a couple days of lessons for what would typically be in the next short unit that I'm merging into this unit, which some teachers already do. So it's not like it's something that is kind of an off the wall idea. So we'll have some lessons in here, and then we're going to push that unit test to the following Friday on the 28th. And it's still not a super long unit since we're only 3 weeks in and we have a day off in there. So I feel like we're in good shape. So again, no test this upcoming Friday anymore. We'll have some lessons. I'll just continue to make videos where pertinent for notes, and then we will come back and I'll probably review a lot of the stuff that we did this week when we come back next week. If not this upcoming Friday, if I'm there in person, and then we'll kind of go from there. Um, so for today, we're going to do section 342 in our textbook. So if you guys want to get out your textbook, if you don't have your textbook, you could copy this stuff down into a notebook pretty easily. So I'm gonna get ready to go here. Sorry, I've been on the wrong page here. Okay, so section 342. Again, this whole unit up so far has been working with quadratic functions and doing a lot of operations with quadratic functions, going between forms, finding specific values like intercepts, vertex, and different forms. Um, and then this past section, 341, we worked on solving quadratic equations a lot and factoring expressions that otherwise we didn't think factored in the past. And now 342, we're going to come back to the idea of the discriminant, and we're going to talk about what that looks like in terms of the value of the discriminant in comparison to what the graph will look like. So we'll be calculating the discriminant, using that to state the number and type of solutions, but then also in terms of what that means on a graph, thinking about what that means for the number of x-intercepts. So first things first, we're in section 342. I'll be completely honest with you guys. My page numbers in here are often off online, and I don't have a textbook in front of me at home. So you guys are going to have to help me with page numbers here. But we're in section 342 in our Unit 3 textbook. We're going to be doing example 1 in a sec. So I want you guys to find a blank page near example 1. So I think it's around like page 140 or so, and start copying down these notes. So if you want to, feel free to pause this just so you can write down these different parts. But we're coming back to the quadratic formula. Okay, x equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. And a reminder, we did learn this last semester that the discriminant is just b squared minus 4ac what's inside the square root in the quadratic formula. And the value of the discriminant, remember it's just a number, the discriminant, is going to tell us the type of, or the number of solutions that we have to that quadratic equation. And today we're going to talk about how that connects with what a graph would look like. So we really have these three cases if you want to pause this and make this as a nice chart in your textbook. First option is that your discriminant is positive. If the discriminant is positive, we talked about in first semester how that means we have two real solutions, which should make sense considering if you have a positive number in here inside the square root, then you're going to be adding and subtracting the square root of a positive number, which means you're going to get two real solutions out of this. Remember that the solutions to a quadratic equation, where you're setting that quadratic equation equal to 0, is really talking about the x-intercepts. So if we graphed this, we would have two x-intercepts for our graph because we had two real solutions to the quadratic equation. So that's the first case. Second case is we find the discriminant and we get 0. Okay, in this case, if we think about what this means in terms of the quadratic formula, if we get 0 here inside the square root, you're adding and subtracting the square root of 0. Well, the square root of 0 is just 0. So you're adding and subtracting 0, which means this plus and minus part kind of goes away, leaving us just with one solution. So we have one real solution here. Well, connecting that to the idea of what a graph of an equivalent function would look like, then we'd only have one x-intercept for that graph, which is possible, right? It would have to be the vertex then, but that is a case that we could have. The last case would be that the discriminant is negative. It's less than 0. If we think about that case, we're really going to be adding and subtracting the square root of a negative number. Well, the square root of a negative number is an imaginary number. So we're adding and subtracting an imaginary number, which means we're going to really have two imaginary solutions. So there's no real solutions to that quadratic equation, which means in terms of our graph, since we have no solutions to that quadratic equation set equal to 0, our function would have 0 x-intercepts. It's never going to cross the x-axis, which is another possibility. So the first part of our lesson is going to be calculating the discriminant for a quadratic equation, and then thinking about the equivalent function, how many x-intercepts you would have as a result. Okay, so let's look at example 1. Okay, we're in section 342. It says, for each equation, state the number and type of solutions by finding the discriminant. Okay, so remember the discriminant is b squared minus 4ac. Remember, it's important to remember that we need to be in the form ax squared plus bx plus c equals 0. So in any of these equations, we need to first get the equation in the form ax squared plus bx plus c equals 0. Then we can calculate the discriminant, and then we can think about what that would look like as a graph. Okay, so they gave us 4 to work with. So we can find the discriminant first. So b squared minus 4ac, 3 squared minus 4 times 2 times negative 5. Well, that's 9. Then we have negative 4 times 2 times negative 5. Well, that's going to be 40. So plus 40. Then we get 49. So positive 49 being the discriminant. If we think about what it looks like as a graph, so I have over here just snips of different graphs. So this is the function y equals of this quadratic equation, and it makes sense that we have two x-intercepts there. So we're going to have two real solutions, which means our equivalent function has two x-intercepts. Another one. So this is in the form ax squared plus bx plus c equals 0. Just there's really a plus 0 at the end here. So first we would do b squared minus 4ac. So we have negative 1 squared minus 4 times negative 0.4 times 0. We'll multiply this whole back by 0. That's going to go away. Negative 1 squared is 1. So we got a discriminant of 1. Well, that is a positive number. So that means we're going to have two real solutions. I apologize for my handwriting here, guys. It's going to take me a little bit to get back to writing on my screen. Okay, and then that would mean we'd have two x-intercepts. We see the equivalent graph over here has x-intercepts at 0, 0, negative 2.5 comma 0. Okay, but we have two x-intercepts there. So we're finding the discriminant for this third one. This is not in the form ax squared plus bx plus c equals 0 yet. So we could subtract over the 2x. Okay, first have to get in that form. So you have 3x squared minus 2x equals negative 5. Let's add over the 5. 3x squared minus 2x plus 5 equals 0. Now we can calculate the discriminant. So b squared minus 4ac, negative 2 squared minus 4 times 3 times 5. So be positive 4 minus 60, we get negative 56. Got a negative discriminant, meaning we have two imaginary solutions. Thinking about a graph, we have a graph over here, the equivalent function. If this was y equals, we notice there's no x-intercepts. Let's say no x-intercepts. Last one, get it into ax squared plus bx plus c equals 0 first. 9x squared minus 6x plus 1 equals 0. Now we do b squared minus 4ac, negative 6 squared minus 4 times 9 times 1. 36 minus 36 gets 0. Remember, that means that the whole square root part is going to go away because you're taking the square root of 0, which means we're only going to have one real solution. And that means, in terms of our graph of the equivalent function, we'd have one x-intercept. Okay. A lot of review today. Okay, this whole unit has cycled back into a lot of the stuff we did first semester. Okay, let's flip the page, look at example 2. We have some solving practice in this unit. Okay, so it says solve using the property of square roots. Show that the quadratic formula gives the same solutions. Check your solutions. Explain how the graph of the related function supports the type of solutions. Okay, so let's let's solve this by square roots first. What tells us that we could solve this with square roots? We could put, there's one x in the problem. Right, there's only a single x. That means that we could isolate that x and solve for x. So let's rewrite the problem. 1/2 x squared plus 6 over 5 equals 0. Let's get the x by itself. So first we'd subtract the 6 over 5 on both sides. So we'd have 1/2 x squared equals negative 6 over 5. We got to get rid of the 1/2 in front, right? The big mistake here is people want to square root at this step, but first get rid of the 1/2 in front. So you can multiply both sides by 2 to undo a 1/2 in front. Right, that would eliminate that, right? 2 times 1/2 is 1. So we'd be left with just x squared equals, multiply these across the top, negative 12 over 5. Square root both sides. X equals plus or minus square root of negative 12 over 5. A couple of things we can do here. Let's simplify the square root of negative 12 on top. That'd be square root of 12 times square root of negative 1. Square root of negative 1 is I. Square root of 12, square root of 4 times square root of 3. Get 2 there. So let's rewrite this. X equals plus or minus 2i root 3 over root 5. And then we don't like having a square root in the bottom. So we did this a little bit first semester, but it's going to come up a lot later in the semester. Not necessarily our target at all for this lesson, but it's good to see
we'll practice a ton later in the semester, we have to rationalize the denominator. Currently, this is an irrational denominator. Okay, so how do we do that? Well, to undo the square root in the bottom, we could multiply the bottom by square root of 5 and multiply the top by square root of 5. Why do we specifically do that? Well, square root of 5 divided by square root of 5 is 1, so we're not actually changing the value of this expression, of this um, term we have here, but it's going to get rid of the square root in the bottom. So we have x equals plus or minus 2i. Root 3 times root 5 is root 15 over 5. So that'd be the solution to the equation. It said, show that the quadratic formula gives the same solutions. Check your solutions. So let's just find the discriminant and compare that with what we got here. So if we did b squared minus 4ac, this original quadratic equation, well, b squared, there is no b term, so it'll just be 0 squared minus 4 times 1/2 times 6 over 5. So we would get, so this would go away. Negative 4 times 6 on top would be negative 24 over 2 times 5 on bottom is 10. So we got negative 12 over 5 for the discriminant. Since it's negative, that would mean we'd have two imaginary solutions. We did get that, right? We had two imaginary solutions. Equivalent graph, we see there's no x-intercepts, which makes sense because we got imaginary solutions to the quadratic equation. Okay. All right. Example 3. Look at that one more like that. So it says solve with the quadratic formula, so we get some practice there. We say x equals negative 6 plus or minus square root b squared, 6 squared minus 4 times negative 1 times negative 13, all over 2 times negative 1. Negative 6 plus or minus square root. Let's see. So this would be 36. 4 times 13, that would be, what would that be? That'd be 52. So 36 minus 52, negative 16, or negative 2. Negative 6 plus or minus, this would be 4i simplified over negative 2. Looks like we could divide each of these by 2. And that's going to get rid of the denominator. So we wind up with 3 plus or minus 2i. If you're wondering, like, wait, what happened with the signs there? Well, negative 6 divided by negative 2 is 3. You're probably thinking, like, do we do anything here? Well, we already have the plus and minus case. So when you divide by negative 2, it's still just the plus and minus case. So these would be our imaginary solutions. We see our graph has no x-intercepts. If we graphed y equals this function. Okay. Probably last one, example 4. Okay, so we have 2x squared plus 9 equals negative 8x. So we're solving by the quadratic formula. Let's first get this equal to 0. Let's add the 8x over. 2x squared plus 8x plus 9 equals 0. Now let's solve with the quadratic formula. X equals negative 8 plus or minus square root 8 squared minus 4 times 2 times 9, all over 2 times 2. Negative 8 plus or minus the square root. Well, let's see. So you'd have 64, and then 4 times 2 times 9 is 72. So 64 minus 72, negative 8 over 4. Square root of negative 8. That's square root of 8 times square root of negative 1. So there's our I. Square root of 4 times square root of 2. It's 2. we could rewrite this as x equals -8 plus or minus 2I root 2 over 4. All three numbers are even. They have a GCF of 2. Remember, we're not looking at the root part, so we could divide out a 2 from all of them. -4 plus or minus I root 2 over 2. Maybe thinking, should we separate this and turn this into a -2? You could. You're just going to still have a fraction over here, so they're probably about equivalently simplified. Okay, but there's our answer. So we have two imaginary solutions. Okay, and then remember that means we have no x-intercepts. Confirm that looking at the graph. Does in fact not have any x-intercepts. Okay. All right, so if we flip ahead, I want us to do for homework tonight, section 342, practice problems numbers 1 through 10. Okay, there's a good variety of problems in there where you can kind of work through those. Remember, the answers are in the back of the textbook if you want to look there. That's a great reference tool. I'll check this in when I return. Okay, so just keep that in mind. Some of the assignments I'll do, I'll probably have ways to turn in online. I'll probably try to utilize Alex a little bit while I'm gone. But for today, work on this in your textbook, and then I'll check it in when I return to class. Okay? Remember, if you're ever gone, you can check the calendar online for what we're doing that day. I'm going to continue to work on updating it. It's just I have to change a lot of the things that were planned because of obviously being gone. As always, if you guys need anything, still reach out. Okay, I'm still very available via email and still willing to help. Okay, but yeah, so I hope you guys had a nice 3-day weekend, and I hope to see you guys real soon.